guys, today I'm going to be going over questions 21 through 25 of the 2019 AMC8. Timestamps will be provided in the description. Question 21 states, what is the area of the triangle formed by the lines y equals 5, y equals 1 plus x, and y equals 1 minus x? Okay, so let's draw our graph. So then if this is y equals 5 and this is 1, then the line y equals 1 plus x would look something like this. And the line y equals 1 minus x would look something like this. So from here, let's see where these two lines intersect. So y equals 5 and y equals 1 plus x intersect at 5. Let's plug the value in to see where they intersect. 5 equals 1 plus x. X equals 4, so that would be 4, 5. And y equals 5 and y equals 1 minus x. Y equals 5, y equals 1 minus x intersect when y equals 5 and x equals 6. So 6, 5, negative 6, 5. Or no, that would be negative 4, 5. Sorry. So we know that this is negative 4, 5, and this is 4, 5. So we know that this length is 8. And we know that this height has to be 4 because this is a length of 1 and this entire thing is length of 5. So now we have the base and the height, so we can calculate the area. So the area is 8 times 4 over 2, which is 16, or E. Question 22 states, a store increased the original price of a shirt by a certain percent, and then decreased the new price by the same amount. Given that the resulting price was 84% of the original price, by what percent was the price increased and decreased? Okay. So first of all, let's say that the original price of the shirt was just $8. Okay, and let's say that the percent that you're increasing and decreasing by is X. So what we want to do now is we want to find X, essentially. So we can set up an equation by using this information right here. So we know from this that the shirt price, or A, multiplied by the amount that it's shifting to, or 1 plus X, because this is the original ratio and this is the amount that's being added, and then decreasing by 1 minus X, because this is the original and this is what's being subtracted, is equal to 84% of the original price, or 0.84 times A, the original price. So we can solve this equation for X. We can divide both sides by A, and then see that this is a difference of squares. So multiply that out to get 1 minus x squared equals 0.84. So then subtract 1 from both sides. Negative x squared equals negative 0.16. Then x squared equals 0.16. And then by what percent was the price increased or decreased? X equals 0.4, because x cannot be a negative number. So then 0.4 is equal to 40%. So the answer would be E. Question 23 states, after Euclid High School's last basketball game, it was determined that 1/4 of the team points were scored by Alexa, and 2/7 were scored by Brittany. Chelsea scored 15 points. None of the other 7 team members scored more than 2 points. What was the total number of points scored by the other 7 team members? First of all, let's denote P as the total number of points scored total. So, Alexa scored 1/4 P, and Brittany scored 2/7 P, and Chelsea scored 15 points. Let's denote all the other points scored by all the other team members as T. So, A plus B plus C plus T must equal P. Let's plug in the values we know. We know that A equals 1/4 P, plus B who equals 2/7 P, plus C that equals 15, plus T, which we need to find. So then subtracting from both sides, we can add these two together to get 15 over 28P. So this means 15 plus T equals 13 over 28P. So now what we can see is that 15 plus T must be divisible by 13 to create an integer, and the total number of points has to be an integer. So if we can find a value of 15 plus T that is divisible or is a multiple of 13, then we know the total number of points scored. So let's try 15 plus T equals 13 first. That wouldn't work out because then T would be a negative integer. What about 15 plus T equals 26? That will make T equals 11, which would work out because that's a positive integer. And it fits the condition that none of the other 7 team members scored more than 2 points. So the answer is B, 11. Question 24 states, in triangle ABC, point D divides side AC so that AD to DC is equal to 1 to 2. Let E be the midpoint of BC, or BD, and let F be the intersection of line BD and AD, or AE. Given that the area of ABC is 360, what is the area of triangle EBF? Okay, so here we can use something called mass points, where you assign a certain mass to each point on something. So let's just do that. So we can assign A a mass value of 2 and C a mass value of 1 because AD to DC is 1 to 2, and D a mass value of 3 because it's just A and C combined. Now we can tell, and E is the midpoint of BD, so we know that B must also be 3, so E must be 6. We know that F has to be 4 now because 4 plus 2 equals 6. So now that we found the mass values for each of these points, we can start thinking about the area. Okay, first of all, let's think about, the triangle EBF in relation to triangle ABF. So here it's just going to be the area ratio is just going to be the base ratio because the heights are the same. So EF to AE is 1 to 2. So the area is 1 to 4. So ABF is 4x for here and just x for triangle EBF. Now let's think about the entire triangle, ABF in relation to the entire triangle ABC. So here again, triangle ABF is going to be in direct relation to the bases. So because BF to BC is see here, we can have this be 1, and then this is 2, so 1 to 2. The areas are also 1 to 2. So because ABF is 5x, ABC has to be 10x. Now we know that 10x equals 360, and we know now that x equals 36. So the area of EBF, which is x, is equal to D, 36. Question 25 states, Alice has 24 apples. In how many ways can she share them with Becky and Chris so that all of them have at least 2 apples? So first of all, let's assign 2 apples to Alice, Becky, and Chris. So if they all get 2 apples from the beginning, then there's 24 minus 6, or 18 more apples you can distribute among them fairly. Or not fairly, just the number of ways you can distribute them. So to distribute 18 with A, B, and C, let's sort of draw it out, okay? So let's say there are 1, 2, 3, 4, 5, 6, all the way to 18 apples. Well, to divide all of these apples up, you would need 2 little intersections in between them to separate them into 3 parts. For example, everything on the left of this intersection and everything in the middle of this, everything in the left of this intersection could be A, everything to the middle could be B, and everything to the, right could be C. And you can divide them into 3 parts by using 2 little bars. So let's count the total amount of things you can arrange. So that would be these 18 circles plus these 2 bars. And what you're doing is you're choosing 2 spots, or 2 things to be the bars. So that would be 18 plus 2, choose 2. So what is 20 choose 2? Well, 20 choose 2 is just 20 times 19 over 2. That's 190. So the total number of ways she can share the apples with Becky and Chris would be 190. Thank you guys so much for watching. Stay tuned and subscribe for more AMC8 content in the future.